Okay, I'm glad you all came back and you didn't just decide to take a nice long break. But it is my pleasure to have here three alumni who, technically speaking, span 3 decades from the ORC, the 90s, the 2000s, and 2010. Although, if you look at the dates, they actually are a year apart. But, you know, I can still make that line. So what we've discussed and what each of them will do, they will speak for 20 minutes each and discuss with us how the ORC shaped their career in OM. They will talk a bit about the past and about the future. Now, as we move from one speaker to another, we will ask you to ask any burning question or not so burning that you have. We'll keep that part short, and in the end, we will open it up to discussion for the last 15 minutes or something. Okay? So, the first person is going to be Dan Yanku, who graduated from the ORC in 2010 with his PhD under the supervision of Dimitris. And he became a Goldstein Fellow right after that for a year. And then he joined Stanford GSB. And I'm happy to say that very recently, his tenure was approved by the Graduate School of Business. And his research is in the interface of operations, risk management, and finance. And with that, I'm going to let him speak more than me telling you about him.
Thank you, Georgia. Perfect, the slides are up. So thank you very much for thinking about me for the panel, and I should obviously thank the organizers for putting this great event together. It's humbling and at the same time really pleasant to be back sitting at the podium. I used to be somewhere back there in the audience some years ago. So Georgia tasked us to talk about the ORC and OM. So, and as you see, I basically kept exactly the title of the session. So OM past and future, and an ORC alumni perspective. So obviously this presentation will be a little bit personal. So it'll be kind of my view into what exactly is OM and where it has been for me and where it is right now. So please do bear that in mind, and it will by no means be very comprehensive. I'll just focus on a small slice of OM, and hopefully between the three of us we'll be covering quite a bit of the field of OM. So basically, I wanted to go just back a little bit to where OM was for me in 2010. So as Georgia mentioned, I did my thesis under the supervision of Dimitris here in Sloan and Pablo Parillo in ECS. And I definitely benefited a lot from having both of them and different perspectives, which is, again, something that you can only get in the ORC, really. I'll talk a little more on that later. But my thesis was on adaptive robust optimization with applications in inventory and revenue management. And really it was on characterizing and computing optimal or suboptimal policies in somewhat complex systems. And the systems that were of interest were these things arising in supply chain management or in pricing and revenue management. And I pulled this just for fun from my job talk. This was my job talk 10 years ago, and these were also pictures in my thesis. This was sort of my view of OR and OM at the time. So, sorry about that. So there was definitely this kind of creature that was finding its way in some of the proofs that I was working with. It's a polytope with some interesting properties. And then supposedly, this actually had some applications. Obviously, otherwise I don't think I would have gotten a job in a business school. But the applications that I was looking at were really in supply chain management. And I had this nice picture in my slides to motivate, why risk and why robustness might be important when you think about risks in very complex systems like global supply chains. And you can think about suppliers, you can think about consumers. At the time, I had this very nice story, but more or less at the heart of it, inventory was still XT or IT for me. It really wasn't stuff lying on shelves. So it's fair to say that my thesis was very theoretical. And my thesis at the time was arguably much closer to OR than OM. Not that, and this will be something that you'll see as a theme through my presentation, what exactly is OR and what exactly is OM. I'll try to give you a little bit of my perspective on it. So this was back then. And I left the ORC in 2010 with with these nice pictures, but also with a lot of other things. And I just wanted to acknowledge them here because I think it's something that the ORC, it certainly provided for me, but I think it provides for many of the students. So it was certainly solid foundations in OR, and for me in particular, it was solid foundations in optimization, and really benefiting from a very broad perspective, having Dimitris on board with more the business insight and more the problem choice and more the really questioning the application side, and also having Pablo, who was the theoretician, much more on the engineering or the math side even. But this is something that is quite unique to the ORC, and it's very hard to replicate even in other industrial engineering departments, and certainly in other business schools. I also left with knowing everything that I knew at the time about OM, and this is really a big thanks to Recep and Georgia, and also Vivek and many iterations of the theory of OM class, which I took twice, and then there was also a seminar with the same course number, where we'd read papers, and it was definitely very, very valuable. I certainly left with a passion for analytics. Again, a big shout out for Georgia and Recep. Data models and decisions was quite instrumental for my career in many ways. And I left with an amazing network of friends and collaborators, and two of them are sitting next to each other there. But this is something that you don't really perhaps appreciate as a student, but you do appreciate after you graduate, just how important this environment and this network is. And having the sort of common language that all of us speak, and having, whether that's more OR or more OM or more whatever it is, it's really a common glue that brings many of us together. And it's something that you'll carry through the rest of your life, whether it's academic life or even in industry or afterwards. And something that you can leverage, that I've certainly leveraged a lot, and I encourage you, the students, to leverage. And lastly, I left with a lot of questions, research questions, also questions of a more philosophical nature. And one of these questions was exactly this one that I kept posting. And this was, to some of you who were in the ORC at the same time as me, you might remember the lunches with the co-directors, where this was always an ongoing discussion. What exactly is OM? And how is it different than OR? It's something that I still somewhat wrestle with. I don't think I have a full answer to that question. But throughout the presentation, I'll try to give you a little bit of a glimpse of how I've started to think more about what OM is and how it is a little bit different than OR. So where I am right now, as Georgia mentioned, I still do a lot of work on prescriptive analytics and just more methodology. Since this is a session on OM, I won't tell you about optimization. I'll tell you more about the applications. And I'm interested in the applications that are really at the interface of finance, operations, and risk management. And lately, I've been working quite a bit on value chain management. If you had asked me what value chain management is in 2010, I don't think I would have been able to tell you. I knew what supply chain management is, but value chain management, not quite. But I'll tell you a little bit more about the way I'm thinking about value chains. And I've gotten very, very excited about social and environmental responsibility in a fairly broad sense. And I chose to really talk about, for the rest of the talk, there are several things I could have mentioned, but I chose to focus on a couple of problems that I've worked on in the last 3-4 years that are really at the intersection, but they speak much more to this particular area. So social and environmental responsibility. And as a motivation, just stepping back a little bit, as a child growing up in Romania, I grew up on a farm with my grandparents for a big chunk of time. And I always cared about supply chains, primarily agricultural supply chains. They had a very special structure in communist Romania. But if sitting here, it's sometimes easy to forget exactly about who produces many of the food calories that we consume, for instance. The fact that it's really about hundreds of millions of households in the developing economies that are producing about 50% of the world's food calories. And this is usually done in very informal means. It's done basically through very, very inefficient supply chains under numerous financial or operational or informational constraints, with actions that often are fairly desperate, because for many of those farmers, this is their means of subsistence, and the way they respond can be desperate, and it can carry a lot of consequences on the environment immediately as well as long-term. But often we should not forget, these are acts of desperation. So they take certain measures in response to incentives and factors that are around them. and that are designed often millions of, not millions, but let's say thousands of kilometers away from where they are. But they're directly impacted by those incentives. And I think this is a space where I never thought I would actually start doing research in it. I was always passionate about it as at a high level. It's something that I cared about. But it's something that if you think about it more as a research perspective or as an area where you can have impact, there are huge opportunities. There are huge challenges, but there are huge opportunities. And really opportunities around designing solutions for concrete problems that tackle multiple angles and that create solutions that are both economically as well as environmentally sustainable. And I'll try to tell you just about two stories, really, that make it a little bit more concrete. And these are stories that, again, I started working on. And the first story really started with travels. And it started with my PhD student, Joanne de Zegger. So she was a PhD student in environmental science at Stanford. And we had our first project was really about merino wool. Both Joanne and myself liked traveling quite a bit, and we were in Patagonia in Argentina on different occasions. And Joanne was able to find a contact within the Nature Conservancy. At the time, there was a consortium formed from the Nature Conservancy, as well as a couple of retailers, Stella McCartney, if you're familiar with the designer, as well as Patagonia, the company. They were interested in working with a group of farmers in Patagonia to understand how they can encourage those farmers to adopt better practices. One big problem in Patagonia was intensive grazing. What happens is that due to management practices on the farms, grass is no longer able to regenerate, and you have huge amounts of land that turn into deserts. And they were trying to encourage those farmers to step away from these type of practices. And it was a very interesting project that our angle into it was more from an operations management perspective, trying to understand the key players in that supply chain and how the nature of incentives and payments and sourcing practices, how those were encouraging those type of responses from farmers, and how you could encourage them in turn by changing some of those payments or sourcing channels to get the farmers to adopt technologies that might initially be more expensive, but that could carry long-term benefits. And we're comparing, we had some fairly interesting theory, which was based on, if you think more from the OR side of things, it was optimization, it was game theory. We're actually hoping to implement it. What happened was unfortunate because there was a PETA video in 2015 that was exactly focusing on that network of farmers, and they were showing a lot of bad practices on the farms. It was just a couple of bad apples, really. Just a few of the farmers were slaughtering lambs irresponsibly, but basically as a result of that, the entire consortium pulled out, and our project never actually got implemented. But this was an interesting lesson in how, you want to take something from a model to actually being implemented on the ground, and there are certain features and factors that are completely outside of your control that can completely hijack everything. But there were a lot of interesting lessons learned, and we carried many of them with us into our next projects. Now, for the next thing I want to talk about is, I don't know how many of you saw these articles last week. There was a story in The Independent, and there was an identical story in the New York Times. This was on the 20th of November, about palm oil in Indonesia. How many people saw the articles? Okay, so I might not need to make a long introduction, but basically, palm oil is a very, very complicated story, and in particular, in Indonesia, it has had some incredibly devastating consequences. This particular commodity and this practice is associated with it. So for us, this started in 2015 with just a reading group and a lot of field work. So my student Joanne spent many, many rounds, so months in Indonesia, trying to understand what happens on the ground. And this is, again, something that for me, I never used to think necessarily about OR in that sense. But I think if you are to think about a more systemic perspective and really understanding the problems and the applications, you want to bring in the field work. It's something that I certainly wasn't trained as an OR graduate, but field work and really thinking about and learning how to talk to businesses to understand the pain points is something that is critical if you want to implement something and to really make changes. Just two quick words about palm oil. So palm oil is basically It's ubiquitous. We don't really know about it. It's one of the most invisible oils used in many of the products that we commonly use day to day. So think, cosmetics, think chocolates, biodiesel. That was one of the focal points of the article. So it's used a lot. People are not really willing to pay premiums for palm oil because it's not very visible. If you look at labels, you actually don't almost never see palm oil. You see sort of derivatives out of palm. And within the space of palm oil, Indonesia is responsible for 53% of global production. So it's by far the biggest player. And out of that, about 40% is production on these small farms, so smallholder farmers. Think here, roughly 2 hectares of land. Now, what does the typical supply chain look like here? And this is, again, in Indonesia. So you have a palm plantation, and palm basically in Indonesia grows around the year. So every 2 weeks or so, a palm tree, they're very productive, they would produce roughly a fruit bunch of about 50 pounds every 2 weeks. And farmers harvest these kind of fruit bunches. They work on particular schedules. They work by themselves with the family, or if they're a little bit bigger, they can actually pay for labor. They harvest these things and they sell them. Now, whom do they sell them to? Well, sometimes they are able to actually sell directly to a mill, and then they get a larger price. But what happens very often is they cannot sell directly to the mill. They sell through intermediaries, through these middlemen. And these middlemen are responsible for transportation. They carry the fruit to the mill. And the role could stop there, but very often they actually act as financing middlemen. They pay the farmers to purchase the fruit at a lower price, and in exchange, they deliver the fruit to the mill. One of the reasons why they do that and why that works is that mills tend to pay with delays. There are a lot of delays in these supply chains because mills are cash constrained. They're not very flux in money. So their working capital doesn't allow them to make payments on the fly as they collect the fruit. They can only pay when they deliver to the refineries, and that happens usually once a month or so. And that's the point when they can actually make physical cash payments. And since farmers prefer to have less cash, but they would rather have it quickly, what happens is that they sell through these intermediaries and they get fairly low prices. And at the mill level, basically, the fruit gets processed. And then, as I was mentioning, the mills eventually sell to these refineries later. Now, one big problem with this is that the farmers operate with fairly low productivity, and that's for a range of reasons. Often they have these aging plantations. These palm trees are fairly old, and they reach maturity after 7-8 years, but after about 15-20 years, the productivity goes down, and you cannot get the same yields. They cannot afford to do replanting because that's fairly expensive. And also, they cannot afford to invest a lot in improving productivity. For instance, here you might think of improving productivity by picking the ripe fruit at the right time. So there are many different kinds of things that you could do, but all of them need a lot of money. They need a lot of, and they cannot afford those things. They basically just harvest in a very informal way. And because of that, one of the means to improve their livelihoods is to resort to deforestation, and deforestation through burning, the slash and burn. Basically, you cut down rainforests to start a new plantation. And this is often done on peaty soils. So these are soils that have sequestrated carbon for millennia. And basically, when you cut down and burn peaty soil, you release huge amounts of CO2 into the atmosphere. And this is where Indonesia, basically, when this started happening at a large scale, they jumped to number 4 in terms of in the world in greenhouse gas emissions. From basically not being on the map to number 4. This was, I think one of the articles was mentioning this. It was the single biggest CO2 emission in 2 millennia. It was estimated, and that happened, and it's huge. So just to give you a sense, it's on the magnitude, basically the entire state of California in a whole year emits about half of that. So it's a gigantic amount. And what we're looking at, so there's this inherent environmental problem, which is only getting worse because the demand for palm oil is not stopping anytime soon. There's huge demand to just keep purchasing whatever is out there. At the same time, you have this issue that smallholder farmers are barely making a living. So there are huge opportunities to improve their livelihoods. Question is how to do it. And we have several projects in this space, just to give you a sense of, so in one project, we're trying to look at what would happen if you reduce the payment delays, if you manage to make these payments earlier to farmers. And you can do that in a variety of ways, but the question is, could that be an economically sustainable incentive? So could it improve the livelihoods of farmers? And maybe some of that extra cash that they have could find its way into improvements on the harvesting, which in turn could be larger volumes for the buyers. So that could make the entire scheme financially sustainable. But the question is, could it also help with reducing incentives for deforestation? And what happens is it cannot help with everything. So it might help financially, so the economic side looks good, but it only increases incentives for deforestation. So you want to offer these type of promises or incentives in exchange for certain requirements. And now we're in the process of trying to implement something like this in Indonesia and in Borneo. Another example is to try to design a platform that would bring together farmers with the buyers in a more systematic way, in a more transparent way. So think, for instance, of a platform that allows you to record exactly where the volumes are being transacted and knowing exactly which prices are being used. And this would allow you to have much improved traceability. You can actually know where fruit changes hands. How am I doing on time? Almost out? Completely out? Okay, I'll be fast. So another example is to think about innovating schemes to provide financing for these farmers, how to encourage them to shift away and to invest in a different type of fruit or change their plantations. And all of these things really, this is just a small list of many of the questions that you could ask. And many of these questions, I won't have time to go through them now because poor time management, but all of them can really benefit from a very disciplined OR approach. You can formulate these kind of questions once you've had a good understanding of what the problem context is. You can formulate them as your favorite optimization model or your favorite game theoretic model, your favorite stochastic model. There are many things that you could use in terms of capturing the essence of the problems, but at the same time, you want to be a little bit careful in capturing the right incentives and the right capturing people and their goals and the organizations around them. Whenever it comes to especially implementing these solutions, this is something that perhaps we don't pay too much attention in OR, but it's really important to understand what drives people and what drives decision makers, and even capture it in our models. This is not something that's exogenous. And I think to a large degree, the ORC really trains us very well in many of these dimensions. So I'll end on a positive note, kind of saying that I try to focus on, you see here a long list of things, and I'm sure Ilan will tell you more about how mechanism design and economics could be merged with OR and OM. We've seen many of the other topics yesterday, but my take on it, and that's why I focus the presentation here, is I think OR and OM can play a huge role as a glue for coordinating many other firm functions. Many of the problems that I described require a thorough understanding of financing schemes, of accounting, of even marketing, how exactly you explain certain terms and to farmers so that they adopt them, as well as social and environmental issues. And sorry for going over time, but I'll stop here.
We still can be fine. Thank you. If there is one very burning question, we can take it. Otherwise, we will leave questions for the end. No? Okay. So now we will have Ilan, who is going to give us a little bit of a different perspective. And Ilan graduated from the ORC in 2009 after he got his undergraduate degree from Pontificia Universidade Católica de Rio de Janeiro, very badly pronounced. In a way, Ilan is my nephew because his brother was my PhD student. So we are related. But after he graduated under the supervision of Asuman Ozdaglar, Munzer Dale, and Arona Simoglu, he had like several advisors. He went basically to Microsoft, where he did a postdoc, and then he joined NYU, where he's already a tenured professor for about 2 years now, almost, or something. 6 months? Oh, okay. Congratulations. And Ilan works on learning, pricing, mechanism design. But on that note, I'm going to let him tell you more about it.
Thank you very much, Georgia. It's a great honor. It's a great privilege to be back here. I have to say that when I get an email from Georgia saying, hey, can you please come to MIT, talk about the past and future of OM, my reaction is like, oh man, I'm not old enough to be giving talks like this. But then she threw me a lifeline and she said, make it personal and say how the ORC has influenced your view of OM. So just like then, I've struggled with what exactly OM is and what should be my role within OM. And I'm going to talk a little bit about that and how that has played into the kind of work I do and how that also shapes what I think the direction that OM is going. So just a caveat, I realize now that like more than half the audience is alums and faculty, but I kind of built this talk kind of thinking of a student in mind. As in, if I was here, like when I was a student, what would I have liked to have known a little bit about what are sort of like the frontiers of OM in a way. So let me start by going back 10 years ago. So this is me trying not to look very stressed as I was on the job market. This is, so that's exactly 10 years ago is exactly when I was applying for jobs. I was applying for jobs in a bunch of different disciplines, including OM. And I accepted a job in OM without exactly knowing what OM was, to be honest. I had taken Retzeff's theory of OM, but that was about the extent of my interaction with OM before starting my job. So I get to NYU, so I took a year off Microsoft, but I get to NYU in 2010, and I started asking people around, what is OM? And I think if you ask 10 different people what is OM, you'll get 11 different answers. And a lot of them have to do with things like production processes and inventory. And I took the Wikipedia definition here, and I put here, operations management is an area of management concerned with designing and controlling the process of production. And it feels narrow to me, but I got a lot of definitions in this spirit. And I started thinking about what should I work on? Should I work on production process? Should I work on something like this? And if you look at what are these big success stories in OM, a lot of them have to do with production processes. You look like all of the inventory control, like SS policies, echelons, like multi-echelon systems. A lot of that is very much in this area. But as Dimitris was saying before, somehow this definition feels very 1950s in a way. It feels very much like related to the US economy when MBA programs were created and not related to the US economy today, right? So I started thinking about what is a way to think about OM that is useful today. And in particular, there are people who are critical of OM because of this. So for example, Gerard Cachon a few years ago gave an interview and he was asked, what would you recommend to new PhD students in OM? And his answer is, get out of this field. Go to climate science, go to computer science, go to something more important than OM. And I respect Gerard a lot, but I very much disagree. I very much disagree with that answer, because I think OM is a very, very exciting area to be in if you think about it broadly enough. So again, the point that Dimitris made, which is the MBA program was created in the 20th century. It was created during a golden age of American manufacturing, where inventory and production process was at the very heart of what the US economy did. But look at the largest companies today. They're Apple, Amazon, Microsoft, Google, Facebook. Don't know if this order is accurate as of this week, but it was accurate a week ago before they all started crashing. But these are all tech companies. There's definitely some operations in them, especially Amazon. But what?
Walmart captures all of those together.
Yeah, okay. So Walmart is, did they make it to the top 5? No. Okay.
Just 2 million people. I think they actually work on
Yeah, but what? It's a correct statement. This was a week ago. These are the biggest companies in the US. And the MBAs want more and more jobs in tech. They still want finance and consulting jobs, but at NYU, there's a big push towards getting MBA into tech jobs. And I feel that somehow we as a community, we have to be relevant with this, within this world that we're operating in, where tech becomes an increasingly part of our story. And how does OM stay relevant in this business environment? So the way I've tried to think about this is how do we, as people in OM department in business schools, how do we deliver enough value to our MBAs? And I've tried to think about this here, especially as in like, what is my competitive advantage when I'm in a business school? As an ORC graduate in particular, what skills do I have that other people in a business school don't have? And I feel that my number one skill set that a typical person in a business school doesn't have is that I'm trained as a problem solver. And what do I mean by this? Is that we are trained, we OR graduates, we're fundamentally rooted in engineering, in the sense that we think about systems and how to optimize them, how to understand them. Even if our systems tend to be more abstract, in generally, what we love to do is tinker with systems and improve them. And people in business schools aren't really trained to think like this, as surprising as that might sound, because most people in business schools, at least the quantitative people, are trained as economists. And economists, they think about questions in a very different way. So I have tremendous respect for economists. I'm partially trained by an economist. But the economists like to think about policy questions and interventions in markets and things, but not really how to solve business problems. So if you tell an economist, you're in charge of this business, how do you improve it? They often don't wanna, they think that's not a research question, right? So, but we very much think that's a research question. And I think that means we have an advantage, which is we really are the only people in a business school thinking about how to run a business. And in a sense, we can be sort of these engineers within the firm, and that way we can add a lot of value to the business school. And I think this is at the heart of why OM departments are hiring left and right. It's because we're really delivering a lot of value, and it's not about production processes or inventory, but it's about this way of thinking, bringing this engineering way of thinking into business schools. And I don't want to say this is my definition of OM, because OM is broader than this, includes a lot of people that are not like this, but this is how, being an ORC student, I've been able to find a way into OM. And what I wish I knew when I was graduating, as in like sort of like what could be my value proposition within a business school. And as I said, if we think about this way, there's a lot of excitement in business schools for what we're selling. Every business student wants to run a better business, wants to be a better problem solver. So at the heart, what I think is that we've struggled a lot with like, how do we separate ourselves from OR? And I kind of feel that's the wrong question. I feel like OM, a lot of the value that we can come back is kind of being applied OR people and being people in the business school who can actually solve problems. And now let me go in the future direction, as in less me philosophizing here and what I think are some interesting problems, which is when I try to think about problems, some of the things that I try to think about are what are some new business problems that we can bring this kind of engineering thinking to solve them, or what are new things happening in engineering and computer science that we can bring in to solve business problems. So I'll mention a couple of them. The first one that I'm going to mention is online marketplaces. Online marketplaces is a topic that I've been very excited now for a few years. Many of the most exciting companies of the last few years, they don't really do classical OM. They don't have inventory. They are marketplaces. Think Uber, Airbnb. These companies, what do? They match supplier with demand. So they do OM in this very abstract way, but they do OM via like marketplaces that we can try to engineer and make them better. And a few years ago, I asked a senior person in an OM department, what do you think are good questions in marketplaces for OM people? And this person told me they aren't. These people don't control their supply. They don't. And I think that's a mistaken view. I think we should very much be thinking about questions like this, where we don't do classical OM, but we think about how to improve the way these companies run and potentially like how do we engineer these marketplaces to run better. And now let me give you some more specific examples that questions related to marketplaces. So a first question is, I think a first order question is how centralized should this marketplace be? And if you think about Uber and Airbnb, they make very different choices. Uber is a very centralized marketplace in the sense that you call a car and you don't control who the driver or the car that is that comes to you. You have a limited amount of control if you want a big car or small car, but very little control. And while Airbnb, it's a very decentralized marketplace where you show people lots of houses and people pick whichever house they want. And obviously, this is driven by the very different problems these companies face, right? So Uber, in transportation, if you get into a suboptimal car, it's not a big deal. And if you rent a place that's suboptimal, it's a much bigger deal. But in general, if you're running a marketplace, how do you think about centralization versus decentralization? If you're centralized, how do you think about dispatching? How do you think you have to do the matching, right? So how do you do the matching? Very classical questions in OR and OM here to be answered. If you're decentralized, how do you control the information? What do you show to make people make better decisions? An important question is, how do you think about market thickness? And what do I mean by market thickness? So if you think about a marketplace where suppliers and demand both arrive according to Poisson processes, for example, do you match them immediately upon arrival? Or do you try to hold them up a little so you can try to find better matches? So this is a big problem. For example, with Uber, if you have to assign a person right away to a car, you're much more constrained than if you can wait a minute or two. So Uber is trying to create products that have this market thickness in there. Another area where market thickness is super important is online advertising. For example, if I'm Facebook and I'll let you bid on an ad for, I only want to advertise to women who are 27 years old and live in this Boston suburb, then you're going to be the only advertiser there. So I can't run an auction to sell that ad to you because you're going to be the only bidder. So if you're an online advertiser, you have to think very carefully about what is the appropriate level of market thickness, as in what level of discretization are you going to give to advertisers? How do you handle pricing in these models? So for example, if you're Amazon, the number of SKUs there is, I heard recently, is in the billions. They don't fully control pricing on these billions, because when I say that, you also include in the Amazon marketplace side where they're serving as fulfillment, as a fulfillment service. But when you have very, very complex sets of products, how do you think about a very, very large set of problems? How do you think about pricing? And for example, in Airbnb, prices should be changing according to check-in, check-out dates. How do you respond to things like this? How do you ensure suppliers do what you'd like them to do? So in classic OM, you have full control over your supply. In marketplaces, you don't, right? So here you have to bring game theory thinking, right? Incentives into play, and how do you put those into marketplaces? And how do you maintain quality, right? For example, most of these markets have some sort of reputation system. You get a number of stars after your transactions. But there's, for example, a recent paper by my colleague at NYU, John Horton, showing there's a tremendous amount of reputation inflation in these systems, and everybody gives each other 5 stars. So if everybody's giving each other 5 stars, this has no role to play in maintaining quality. So what are the tools you have here? Can you keep a reputation system working in the long term? And I think all of these are unsolved questions. And here's a plug. If you're interested in these topics, come to Stanford in June 4 to June 7. I'm helping to organize 2 events there. One is the Marketplace Innovation Workshop, which is an yearly event I've been doing for the last few years jointly with Gabor Ventrab, Ramesh Ohari, and Kostis Maglaras. The Marketplace Innovation Workshop is a place designed to bring in OMOR people together with computer scientists and economists and think about marketplace questions. And Dan here is helping run the Revenue Management and Pricing Conference that comes right after it. And I'm helping to coordinate as the section chair. But please do come and attend if you're interested in this. Engage our community if you're interested in these kinds of questions. I think these are fascinating. Now let me give you a different flavor of other areas that I think are growing in OM. And I said another area that I think OM can benefit a lot is learning from other disciplines. For example, we can bring in machine learning ideas to how to run businesses. And let me just give you one example of an application that connects, I think, closely to something that Adam was discussing yesterday. So let's say you're choosing the assortment for your store. Oh, there you are. I just mentioned your name. So if you're running your assortment for your store, in a classical OM problem, you just choose a set of things that you're going to put in your store and you're done. But right now, you maybe run an e-commerce website and you choose what things I'm going to show you as a function of your browsing history or as a function of your cookies. So now not only do I have to optimize this, but I have to take into account the contextual information that is relevant. So in the language of machine learning, this is no longer a multi-arm bandit problem. This is a contextual bandit problem, because every day I'm facing a slightly different problem, and it's using information that I have in that day. And there's also lots of people using ideas like this also. There was a whole workshop that I think CP was there with me in Minnesota a few months ago, and Georgia was there, on how to think about bringing these ideas also to inventory management, supply chain management. There's the work on big data news vendor from MIT a few years back. So there's also a big push also in bringing in these sort of engineering and computer science ideas to OM. And let me just wrap it up here by saying, look, I think it's a really exciting time to be in OM. And I think it's exciting because the nature of businesses is changing, the economy is changing fast, and that means there's a lot of new problems for us to study. And these are problems that we're very well equipped, being trained in OR to think about. And OM groups are thriving, so we're, as I think Dimitri's mentioned, we're the biggest hires of people with OR degrees. And because I think we're the only people going to business schools with this kind of way of thinking, with this problem-solving way of thinking. And I think this key to our future success as a field is making sure that we're aligned as a community with where businesses are going, with where MBA students want to do. So thank you very much.
Any questions that are burning? No one? Okay, last but definitely not least, now I am fast backwards, not forward, to 1996, when Chang Piao Tio graduated from the ORC under the supervision of Dimitrius. Hopefully there was no co-advisor that I forgot, like I did for Dan. And because of a bond obligation, he went back to Singapore. Very sadly that he didn't stay in the US, for many of us. True. And currently he's serving as the department head in the Department of Decision Sciences at NUS. And I understand that they have renamed the department as Analytics and Operations. And before that, he actually served for a year as acting deputy dean, and it sounds like he ran fast away from that type of role. But basically also he has served the community a lot over the years in terms of editorial positions by being area editor in our flagship journal Operations Research, in supply chain and operations management. And if that job wasn't enough, after that round ended, then he went to management science and he's now department editor in optimization. He works a lot on optimization under uncertainty, discrete choice models, logistics and supply chain, combinatorial optimization, and many, many more topics. But I think I should let him speak. Thank you.
Thank you, Georgia. Yeah. It's always good to be back in MIT. Yeah. So I guess you all know now that I'm the guy from the 90s. I'm the oldest among the three, and in fact, no matter how old you go, you become, coming back to MIT to give a talk is always special because you always see your supervisor and also thesis committee members, Tom, sitting in the audience. So it felt like going back to thesis defense. And I have not done that for many, many years. Yeah. But anyway, OM during the 90s in ORC, I guess to put it in a simple manner, in fact, I don't think there was much OM activities in the ORC during the 90s. I think then when I was a student, we were studying Tom's book on network flow. Dimitris introduced me to approximation algorithms. So my thesis is actually on optimization. And we have not done any class on inventory. I think supply chain, the word supply chain is still relatively new then. Howley has just published his Buwick paper. So OM in the 90s in the OR Center is actually, we don't have a lot of coursework, but I'm glad to hear that Georgia has, I think over the last 20 years, looking at the two gentlemen sitting over there, you know that they are very well trained in OM. So for me, I actually learned OM through the painful manner, because over the last 20 years, as an ORC grad, I went back to Singapore. I spent my last 20 years building up the Department of Operations and Analytics. So I actually taught OM for the last 20 over years to businessmen who may not understand the OR models. So let me give you a different perspective. In fact, perspective of OM is, of course, colored by my experience in Asia. And before I move on, I just want to correct a statement from Georgia. I'm no longer the head of department in the business school. I started off as vice dean of research, then I move on to deputy dean, and then I move on to head of department, but now I'm officially out of admin. I'm actually running a new institute now in OR and analytics, and I happily pass over the headship to Melvin, who is also an ORC alumni. So Melvin is heading the department now. I will say something more about the Institute of OR and Analytics at the end of this presentation. Now, OM, I guess, OM in the early days, OM is about when I started to embrace the field. OM to me is about the use of OR techniques to solve problems in operations, either in production system or service delivery systems. And if you look carefully at in fact, this work cloud is actually prepared by Chris. The journal MSOM is publishing a 20th anniversary issue. So I got this list of all the articles published in MSOM from 1999 to 2018. And if you look at all the research published in MSOM, you see that the keywords are supply, demand, inventory, capacity planning, a little bit of information management, and you see a small news vendor model feature heavily in the OM literature. So these are this is the work cloud prepared from the titles of all the articles published in MSOM over the last 20 over years. Now, but in the past, I think OM actually has a big problem, because if you look at the OM in research is about model building, is about finding optimal policy. But if you look at OM in industry, the interest in OM in the business school is actually sustained by two very important developments. One is basically the concept of lean. If you talk to OM practitioner in the industry, to them OM is about lean manufacturing. To them OM is about Toyota production system. So this work by the MIT scholar, The Machine That Changed the World, has actually a tremendous impact on the industry. And later on, the emergence of the field, supply chain management, companies become interested in building sophisticated IT systems to solve the operational problems in the supply chain systems. And again, that fueled the interest in OM. But if you look at the research in OM in the past, I think has focused too much on the processes. We do too much on process modeling optimization. We forgot about the information system aspect. We forgot about the lean, the waste reduction optimization aspect. So at one point in time, the OM scholar has a problem, because you see that doing research in OM is very different from doing teaching in OM. When you go to the classroom, you cannot talk about your inventory model, not even news vendor, because the students in the typical MBA program, especially in Asia, can't even cope with the concept of variance. So you won't be able to cover the OR models in the typical OM classroom. So I guess this is what prompted Chris Tang to justify that the OM scholars in business school should command a very high salary, because you do research in one thing and teaching in another area. So that's why we are doing two different things. You should get more pay. Yeah. But I personally, I think this problem has persisted for several decades. But I think OM in the future has actually a lot more promise. And in fact, I share Ilan's perspective that moving forward, for the field OM to thrive, I think we have to look at the other machine, the machine learning. I think the OM scholars have to be able to embrace data, embrace the new science in data management and the big data and analytics. And we have to figure out ways to bring AI, to bring machine learning into the OM portfolio. And in fact, this is what I downloaded. You see that this is the Google search trend from 2004 till now. And this is the interest in the OM profession over the last 20, 30 years. But if you look at the blue lines represent analytics, you see that the interest in analytics peaked around 2012 and declining slowly. AI was hot, but then declined, and then slowly in recent years started to pick up. Now, for OM in the future to thrive, my personal belief, I mean, this is my personal take, and I'm trying to push my colleagues in NUS Business School to embrace this, is that we have to bring data into our teaching of OM. OM should not be about processes, about model, but it should be about our ability to analyze data, to look at the point of sales data, to look at the supply chain, the ERP data, so that we can build models, so that we can make better decisions. And I believe OM, if we can embrace this new future, I think we will have a lot of market values, at least within the business school. In the past, I have, working as dean and head, I always have difficulty getting my dean to fund a line in the department. My dean, who is an economist, always say that we are a bunch of mathematicians in the Department of Analytics and Operations. But in recent years, he changed his tone. He wants us to hire more people in analytics. So the surge in interest in analytics have actually helped the OM department, at least in NUS. Now, and I think that the research in OM should also move away. We should change from our traditional mindset of news vendor modeling, static optimization, to embrace the new reality that the companies these days are actually building real-time. They are putting sensors on their machines. They are developing real-time IT systems to allow the company to manage the production system or even service delivery system in a much more efficient manner. So we have to be able to move away from the traditional mode of research in OM to talk about how to make dynamic and adaptive decisions. So we have to move from static optimization to to do more dynamic and adaptive optimization in the way we approach OM problems. And of course, this is in fact very exciting, and in fact at the MS and OR journals, I noticed that we have been receiving a lot more submission these days on this kind of reasoning, the online marketplaces, the online auctions, online optimization, online convex optimization, so on and so forth, have actually tremendous value in the way we approach operations problems. Now, while we are talking about trying to build models in a more dynamic, adaptive manner, today actually I want to focus on special topics on process flexibility, which is also an area I think whereby the MIT scholar has made a lot of contribution, especially Steve. But I don't see Steve and David and about Ye Hua is here. So David and Steve, I think over the last decade or so have actually introduced a very important concept into the OM research agenda. It's about the area on process flexibility, how to design flexible and efficient systems so that while we are doing dynamic and adaptive planning, how do we ensure that our systems can allow us to do this kind of system adaptive planning in a simple and yet efficient manner. Let me use this concept about on toolchain. How many of you here know toolchain, by the way? Okay, only half of you know this concept about toolchain. Now, this was a concept I think pioneered by Steve and his student Jordan in a paper about 20 over years ago, whereby they observed that actually in many typical production systems, if you look at dedicated production systems with fixed number of plants and a fixed number of products. If the production structure is very rigid, as in this case, without any flexibility, you'll find that the ability to pre-configure the capacity of the plant to respond to the dynamic and random environment is quite limited. When demand changes, you will see that some of the capacity will be left unused, some plants will be overutilized. So this creates a lot of mismatch in supply, in matching supply and demand in a typical production system. On the other hand, if you look at the full flexibility system whereby every plant can be configured to produce all products, this is the best way to use dynamic and real-time data to reconfigure your production plan. But this leads to a very messy production systems. And Steve actually made a very interesting observation by having a limited and simple process structures like a tool chain, chaining the plant and the products in a long chain manner. You can actually have performance very close to full flexibility systems. So over the last 2 decades or so, actually I've been trying to study this phenomenon, and so I will in the last, how many more minutes do I have, Georgie?
You still are doing well because we have about half an hour.
Half an hour more. Okay, so let me share with you some of the insights.
The audience participation.
Okay,
So
let me share with you some of the insights that I've been learning from this particular problem. I'm actually excited by this problem because I've spent the last 2 decades trying to answer these questions. Does this phenomenon generalize to other supply chain systems or other service delivery systems? Tool chain has been studied by a lot of scholars, but does this phenomenon exist in many other production or service delivery systems? And you'll find that this is a difficult problem because even understanding the performance of tool chain, very simple structure, we know that it works very well, but all these insights are obtained mainly through simulations. So trying to understand the mathematics of the tool chain systems takes, I think, Yehua, your thesis is basically on the mathematical analysis of a long chain in a balanced systems, whereby the plant's capacity are identical and demands are IID. So the math in adaptive optimization is actually very, very difficult. But I guess to embrace the new research program in OM to be able to make real-time dynamic and adaptive decisions, we have to overcome these mathematical hurdles. Now, let me show you why tool chain is so fascinating. In fact, the breakthrough that we have actually comes from Dimitri's robust optimization work. Interestingly, the tools that we ended up using to analyze this class of OM problem comes from the robust optimization literature. And tool chain, in a way, you can see that tool chain is robust because if you have, I show you here the systems whereby every plant has constant 10,000 unit of capacity pre-configured, whereas the demand can vary. Now, in fact, you can show using robust optimizations that as long as the demand varies from 5K to 15K for every product, you can show that the tool chain work as well as the full flexibility system from a robust manner. So no matter how the demand change, your tool chain system is able to reconfigure the delivery plans to adapt to the demand. So when demand is 5, 15, 10, 5, 15, the tool chain system is able to make full use of the 50,000 capacity configured in the tool chain system. When the demand changes to a different set of number, again, the tool chain system can use the real-time info to adapt and maximize the utilizations of this capacity already pre-configured into the systems. Now, if for those who know graph theory, if you look at this picture, you know that this has something to do with graph expansion. So it turns out that you can use the theory of graph expansion to sort of explain why tool chain work in this robust manner. But of course, this is in the simple case whereby your products demands are IID, your plant's capacity are constant. So what one of my research agenda is to be able to generalize this phenomenon to other more complex planning systems. And I'm happy to report that again, using tools from robust optimization, in recent years, we are able to develop a set of techniques to design flexible, sparse, and efficient systems for production planning. Let me use these manpower scheduling problems as an example. So this is the map of Changi Airport. How many of you have been to Singapore, by the way? Only half. For the other half, I actually want to welcome you to Singapore next year. I'm actually organizing MSOM 2019 in the beautiful Marina Bay Sands in Singapore. If you want to find out more about OM, you should attend MSOM 2019 in Singapore. But this is the airport. If you go to Singapore, this is the airport you will see in Singapore. In fact, I look at this is one of the terminal in Singapore, and this is the layout of all the gates in this Terminal 1. So one of the problems that the Changi Airport operations folks are concerned about is about the deployment of their roving teams. So at the gate, of course, you need to, when there's a flight departure, you need to station screeners, security screeners at the gate to make sure that all the passengers are properly screened. But because of the bunching effect of the arrival process, sometimes we have to deploy more than one team. So there's a random demand for the second roving team deployment. And if you do a mapping of the schedule of the gate, for example, this is a particular gate, and it is supposed to remain open from this time interval to this time interval. You can see that the additional roving team can be deployed in many different ways, because after you deploy to this gate, if time permits, you can deploy the same team to a different gate to serve a different set of demand, if there's a realized demand at the different gate. So of course, you can manage these operations in many different ways. One way is to use fixed route. So these are all your jobs, and you can try to partition the jobs into distinct sets, so that in fact, using this, you will find that you need at most 9 teams in a distinct manner. No matter whether there's a job in this particular gate or not, you have a team of screeners who will visit all these gates in a non-overlapping manner. So you can find about 9 disjoint paths through this job. So this is what we call a fixed route system. The operation becomes very simple. Whether there is demand or not, you know that there will be a team of security screeners personnel to man these stations. Whereas you can also use full flexibility systems, deploy your security screeners in a real-time basis. Okay, you can, depending on the realized demand, you can optimize the routes to use the smallest number of personnel. But of course, if you were to do a fully adaptive real-time planning systems, the routes traveled by the security personnel will be very complicated. So the key question is whether a sparse subset holds in this particular setting, and we essentially use a class of robust model. Instead of building this graph, we actually have to use the dual prices. So we perform sensitivity analysis on this stochastic system, but trying to analyze the stochastic system is very difficult. So we replace that by robust systems. And from the robust system, we analyze the shadow price. And from the shadow price, we throw away all the redundant arcs. So these are essentially the idea used to develop these particular structures. And you can see that using this small number of additional arcs compared to the fixed route systems, we can get performance very close to the fully flexible system, yet we use only a small number of arcs within the deployment systems. So the concept of two-chain in a balanced IID case actually holds in this more complicated setting, whereby a small number of arcs added to this fixed route system can perform as well as the fully flexible systems. So this is one phenomenon that actually led us to believe that this idea actually, this two-chain phenomenon actually materialized in many other operational systems. And in fact, there are a few other examples. I think David may like this example on rebalancing vehicles in a sharing platform. So this is a very well-studied problem. A lot of people are now looking at these particular problems on how, in a sharing platform, when say in a bike-sharing platform or a car-sharing platform, how do you move the empty cars around the systems to maximize availability of the vehicles or your assets to your customers who may arrive in random fashions? Now, of course, so we actually did a simple experiment on 10 stations. We have 10 car sharing stations with different arrival rate, and different transition probability from one station to another station, the distance and the travel time proportional to the distance. If you try to simulate these particular systems, because of the transition probability and the arrival rate, you'll find that no matter how you deploy your bicycles or your empty cars in the systems, after a while, you'll find that these empty cars will move to places whereby there is no demand, whereas stations with very high demand could not find the cars or the vehicles. So this creates the situation for the need to do rebalancing in these particular systems. So last year, Jim and his students in Cornell actually did a very beautiful paper on this class of problem, whereby he built actually a fluid models to do the rebalancing activities. And essentially, they reduced the problem into an LP. There's a nonlinear constraint here, but interestingly, they show that by throwing away this, you solve an LP and you still get a very good deployment decisions. Now, I realized after listening to all these talks that I'm the only one who show you equations in this. But I thought it's a crime, right? Coming to MIT OR Center, if you don't show an LP, it's not right. So this is an LP. I think the first LP that was shown to you in this particular workshop. If you don't understand, never mind. But essentially, this is not my LP. This is the LP built by Jim and his students using fluid models. And numerically, they show that this is the heuristic, the fluid model heuristic performs very well. Now, sparse process flexibility comes in after when we ask the questions. Because in these particular fluid models, Jim assumes that all the empty cars can be diverted from any station to any other station. So it's essentially the rebalancing activities is performed on a network with full flexibility. And in that particular network structures, he built these fluid models and do the rebalancing. Our question is actually whether the fluid model heuristic works better under sparse structures. And if so, what kind of sparse structures can you use to do the rebalancing activities? And I'm happy to say that the same techniques that I used to create the Changi Airport example, again, by looking at the robust model and studying the shadow price, we are able to build, okay, so I show you here the rebalancing activities in the fluid model solutions. And using the sparse structures, using the same idea, this is the sparse structure that we obtain, and this is the fluid solutions under the sparse structure that we obtain. And it turns out that, of course, this looks like a silly idea, because I'm actually tying my hand. In the earlier example, in Jim Dye's paper, I'm doing solving a fluid models over the complete graph. So I have more flexibility in solving the fluid models. Here I'm tying my hand, I'm restricting my flows to only selected arcs. And the arcs are selected through some model that I will not cover here. So by tying our hand, by restricting our options to do the rebalancing, we get a different fluid solutions. But strangely enough, this sparse solution actually performs better. So by restricting myself to sparse structures, I realized that okay, this is the actual rider demands. This is the case if you don't do rebalancing. This is the case if you use the fluid-based solutions from Jim's paper. And in fact, by tying myself, restricting myself to flows along this sparse structure, actually I do better using the same fluid heuristic, which is surprising. In fact, we tested this in many different environments and realized that sparse structures plus the fluid model actually works better than a fluid model without considering sparsity, which is quite surprising. And the nice thing about this is that you can see that in Jim's case, when you have fluid solutions over a fully flexible network, you do a lot of unnecessary move. So you move empty vehicles trying to catch demand in the next station unnecessarily. By focusing on the essential arcs, you can actually reduce all this unnecessary movement, maintaining the same availability of vehicles, which is rather surprising to us when we look at this set of numerical experiments. Now, I will end here by saying that I think future for the OM scholars is actually very bright. I think there are a lot of new issues and new problems once we start to embrace the tools of AI and machine learning into our fold. And I gave you one example, but I think there are a lot more other examples that I think the community is slowly trying to uncover. I want to end my presentation here with this announcement that of the setting up of the Institute of OR and Analytics. As I mentioned, we spent the last 20 years trying to build up the operations department in NUS, and last year the university became convinced. We tried a couple of times to convince the university to set up the institute, and last year we succeeded. So the university invested about 11 million in this institute. Essentially, we are trying to build another ORC in Asia, in Singapore. And so if you look carefully at the way we work, we basically just copy what you guys are doing in MIT here. I hope I won't be around at the 65th anniversary of this institute, but I hope this institute will continue with the help of ORC in MIT, of course. So I hope we can do a lot more work together in the future. And next year, when you come to MSOM 2019, I hope to be able to host you in this brand new institute. Yeah, thank you.
So I think on this note, I want to open it up to the audience. We have another 15 minutes because we started 7 minutes late. Actually 16 or 17 minutes. So, Adam?
So thanks for the presentations. My question is obviously I think we all join OR because we want to make impact in the real world through our mathematical abilities. So my question is about, one way we do that is through publications. And I'm wondering about the future of publications in our field. So I posted on my social media about a year ago, the top 10 most cited papers in our field. And Yewa just reminded me of this. And frankly, it's a very embarrassing list of what the most cited papers are. None of us would be interested in reading these papers. Whereas if you look at CS, all the papers are pretty fundamental and many people would know of these papers, including us in this room. So the citations don't correlate to what we think is impactful papers, I think it's fair to say. So that's one issue. And another issue is about interdisciplinary work. Almost every school is encouraging interdisciplinary research. And I think it's very important. I mean, if the CS conferences are getting all these publications visibility, why not publish there if we really care about making an impact? And at the same time, if I'm gonna read any journal, I definitely wanna read an informed journal. Those are the highest quality papers and most interesting papers to me. So what can we do about allowing for more dual publications, just explicitly not worrying about if there's this conference version and a journal version? And generally, how do we just increase visibility before we just get diminished altogether?
Let me just say that I fully subscribe to what Dan Beanstalk said yesterday, that we need conferences. We need conferences where we're publishing. We just need to move faster as a community. I think that's part of what's happening here is that computer scientists they can do work that is much more like, here's an idea, let's move on to the next. And eventually they publish a paper with all these things together, but they're not forced to work for 3-4 years on every single idea they have, which slows us down quite a bit. So I'm totally on board with your argument that we should be publishing in conferences and then publishing them in the journals. If I was editor-in-chief of the journals, I would just get rid of these rules. But I'm not. I'll open up.
You want to be nominated?
No, thank you.
Adam, let me. I just want to confirm. I thought Dimitri's paper is among one of the top 10 cited papers in OR.
It is.
Is it? Are you referring to?
The one with Melvin?
Yeah.
It's by Google's classification, which isn't great, admittedly.
I see. Among OR, huh? Oh, you're referring to Google Scholars. No, I wanted to say this because I think, as I mentioned, OM in the past has had some problems because of the disconnection between research and practice. So the high-impact papers, the highly cited papers are usually papers on problems that a lot of scholars, academic scholars, are interested in, but it has not filtered down to the industry, to the practitioners. But increasingly, I think we see more high-quality papers, like I think Dimitri's and Melvin's paper on the price of robustness. I think I suspect, given the trend, will be at least one of the top 3 in OR, if I'm not wrong. So my point is, the future is looking very bright, and I hope in 50 years' time, your statement will not be valid. And in fact, in the journals, in MS, I think David has been working very hard to try to address this problem. So we have implemented the fast-track submission systems, whereby we encourage the community to submit short paper, short but to the point, to the journals, so that we can process the paper in a super fast manner. So this is one attempt that we are doing to address these problems that you mentioned. But of course, now we are facing some problems because the editor-in-chief, the department editors can say that we should try to process the fast-track paper in a fast manner and forget about all the fussy details on exposition, editorial comments, all this. But the community is not responding. The reviewers, they continue to demand very high standards on even the fast-track systems. So I think it will take some time for this mindset to filter down. Yeah, I don't know, Dan, you have anything to add?
So I do subscribe to the importance of having a faster moving cycle and having conferences. I do want to push back a little bit on this obsession of comparing ourselves to other communities. We have to be a little bit realistic of where we are as well, because if you think about computer science, or you think about economics, or you think about some professions that have established conferences, they have much higher inputs in terms of just numbers. There are many more departments, there are many more, and I'm not saying that we have to live with that reality, but we also have to be realistic about where we are now. And moving forward, of course, if there will be enough scope to have really high quality submissions to be able to maintain, because I think there is also the question of maintaining standards and maintaining, if we just have conferences, we might not have the same numbers and the same submission rates as NIPS, for instance, as a community. So we have to be realistic about where we aim. And of course, there will be changes along the way with the community becoming perhaps larger and starting to bring in more machine learning, but we have to be a little bit realistic about what we want to aim. So I think my take on it is that we can definitely move to a system that doesn't just rely on slow journals and does a better job of bridging what is important and sexy in industry with what is studied and published in journals and published in academia. What that will entail is partly conferences, but also partly kind of changing the way the community acts, and what we should not set too many boundaries to ourselves, and we should try to bring in more of these other disciplines and integrate them in what we deem as our community.
Let me just push back a little bit on this, because there's in the following sense that there was an NSF experiment a few years ago where they took out deadlines from one of their programs, and they said, now whenever we get in enough submissions, we'll put a panel together and we'll evaluate all the submissions. And guess what happened to the submission rate? It dropped by over 50%. So the number of submissions to these programs went down a lot. I feel that the fact that computer science has these pre-specified deadlines just makes everybody sit down and put the things together faster. I feel there are systems in place that these communities have that just make them more agile. And
I'm not pushing back against that. So I certainly agree that having having deadlines is helpful and having these kind of conferences is helpful. What I question is whether we have the numbers to maintain the quality that they maintain right now.
The thing at NSF is called engineering. all the division of engineering is what relaxed the deadlines and the figures are right. So
And decreased by 50%, right? 50-something percent.
it's very early in this process. It just started as of this year. So
But they did an experiment a few years ago. That's what I forgot the exact division they did it with.
But if I may add one more point to this discussion, is one thing that also has to change is the whole review process, in the sense that the reviewers should not see a paper as the last paper somebody will ever write on this topic. That many times it feels like that. So I think the mindset of all of us needs to kind of become a little bit more agile, which I don't see, being there yet. Dimitri?
Changing the subject, I'll start with an observation and a question. So if you look at the history of OM, I believe OM started primarily because in many business schools, OR has not been viewed as a success. There are, to the best of my knowledge, only 2 business schools that have an OR and OM department, ours and Carnegie Mellon. I might be forgetting one, but there are very, very few. So it really did not start very positively. That is, now moving forward. And I would also observe that what historically has happened, OM departments, by and large, has hired stochastics people over the years. Not exclusively and increasingly not so, but historically that has been the case. History can be revisited to analyze, but is not positive moving forward. I would suggest, and I would like your opinion about it, is that, in my view, the future is neither OR nor OM. It is the union, analytics. Why not we all push forward to, and NUS went halfway. How was it, Champion? Operations and analytics. 50%.
Sorry, it's analytics and operations.
Oh, good, 52%. So I would say, all of us have difficulty explaining. All of you spoke to some degree about that. But analytics, because it encompasses everything, and it doesn't have some of the historical baggage, which for some places is positive. ORC has a very positive connotation, but in many other places in business schools is not particularly positive. What do you think about pushing forward to redefine ourselves as analytics, which means you don't have to justify working for Google problems, for Uber problems, for medicine problems, or name it? That's a question.
Oh, of course, I agree with Dimitri's 100%. That's the reason why, in fact, my personal take is, in the past, I think OM has had a lot of impact, in part because we are not addressing the real problem. The reason why I'm so keen to introduce data into OM is that once you have data, you see that you can't hide behind the pretense of fake problem. You can't build model without a real problem, without a context. So in fact, one of the reasons we set up the institute is actually to also sort of try to merge the 2 areas together: operation, research, and analytics. So in the past, OR is about model building. The mission of the institute is actually to bring data into this. How do we build model using data? And we are launching some research programs in this direction. And I have also hired some senior executives from companies so that they can bring their supply chain data into the institute, so that our colleagues, our faculty members can develop teaching cases, do research based on some of the real supply chain data. Yeah. So these are efforts that we are trying to do in NUS.
I wanted to, maybe I should let you speak, but one thing I wanted to mention to your point is I think the society and the field has been moving in what you're talking about. Some concrete examples is the AMSOM Society did this data challenge that maybe Ilan should talk, because you were in the committee, where there were data given by Alibaba, and the idea is people could use this and try to basically define what they thought the important problem is given the data. There is the practice-based competition, which basically encourages how real companies that work with faculty to have an impact. And these are just some examples. So I think the community is moving in this direction. But please.
Yeah, I think your argument is very much in line with what Dan and I said, which is that we really shouldn't be trying very hard to draw these boundaries between OR and OM, and because almost everywhere in business schools the boundaries don't exist, right? It's one department that can hire OR OM people, and I was on a committee that we did we got in all this data from Alibaba, like 100 gigabytes of data, all transactions that happen over 6 months on their supply chain network, and that was highly successful. We got 21 submissions. We gave a prize to Rob Ray from Kellogg for the best paper. I didn't do the hard work there. Dennis Zhang from Olin was the one that did the work of actually getting and cleaning the data and making it available to everybody. But I would say actually my biggest concern is along these lines is that, for example, this is something that's happening at NYU, and I think we have a strong IS group, which is not common in business schools, and our IS group teaches all the machine learning stuff. So we don't own the word analytics. I think in a lot of schools the fight is with marketing, and in a way the question is, who is going to be teaching analytics in the future? Is it us or is it computer scientists? And we have to fight to stay relevant. We have to fight to make sure that when the hiring goes, it's one of our guys that gets hired to teach, and we teach things that the MBAs find useful.
To another angle. So I'm here from 2006. When I arrived to the ORC, there wasn't even a real OM PhD class. And I think that about 10 or 11 years ago, we actually made a strategic decision of multiple major changes due to a committee led by Georgia of changing some of the requirements and some of the expectations from the graduates of the ORC. For example, there was a much more stringent requirement of having to do at least an internship or work that has to do with data. There were requirement to take either to take or to TA MBA courses. As part of creating several tracks, and the OM track was one of them. And again, I don't know if I have a causal proof of that, but I think that this change to me have flipped both the immediate success that the graduate of the ORC had in the market, in the job market. But as I listen to you, I think that one thing that also emerged to me is that each one of you, beyond the immediate work that you did in your PhD, were exposed at the time at the ORC to enough things that kept you both capable and curious and with aspirations to go in different directions that connected with data, connected with real life problems. And maybe for you, Chang Piao, it was more doing it by yourself. And I just wonder if you have any perspective on that. Because when you compare it to actually other PhD programs of our profession, and I think that that's a big source of the problem, there are many programs today that you don't have to take a linear program class, that you don't need to know anything about optimization, and that you can graduate without touching any real data and become a faculty. And to some extent, I feel that that's potentially a major factor that we need to think about. You know, what are we, as we train more and more future scholars, what are we expecting them to know, and what are we exposing to them to when they are in their PhD time? Because I believe that the ORC is a big outlier currently compared to many other programs. Maybe not the only program, but there are many other programs that think about the training in a very different way.
I'm happy to chip in on this. So I think there are quite a few programs, like what we think of as typical more OM programs, that do train students. They do take a linear optimization class or a mathematical programming class. They do take some data class, but I think the way many other programs think about data tends to be different. There is a strong, and I think would be foolish not to acknowledge it, there's a strong push in the OM community towards empirical research. But the way that research is perceived is much more along the lines of econometrics. So closer to economics rather than data-driven decision-making, the way we think about how to use data. So I think some students are...
In some of the leading schools, I don't think that they have to take a linear programming class. They could, but they don't have to.
In Wharton, I think there is a requirement. In Kellogg, there might not be because that program was designed closer to more global with the other departments, so it might be the case. So there is something to be said. I think there are many, many great things about the training that happens in the ORC, which I think, going back to some of the fundamentals, I don't think those should disappear. Things of fundamentals of optimization, fundamentals even of stochastics, more data-driven classes which should find their way in a core curriculum. I think those are here to stay, no matter how we think about them. Now, when it comes to what differs a little bit, and perhaps where the way, and this is again more my view on where OM differs a little bit from OR and where we could have a little more training, is more on the softer side, on the people side. More on, for instance, behavior and more on how human decision makers act. More on, for instance, game theory. I think game theory is also a language that many people in the business school speak. So if you think about, I think it's a language that I view any OR/OM graduate as being able to speak to some degree. So I think that it's about kind of setting a common language to some degree. And I think data is definitely part of that language, and it will become more and more part of that language. It's something that our groups are getting interested in, as well as econ, as well as marketing, as well as organizational behavior. So it's an area where we're at the forefront right now, and I think we need to pedal on that and own it much more.
I think on that note, I will see if Ilan wants to add something. I don't want to put you on the spot, or any of you for that matter. If not...
Can I?
Go for it, go for it. I just want to...
Yeah.
I'll just say thank you for inviting me.
No, let me add to this. In fact, that said, I think the OR training provided by MIT has served us very well. In fact, my only concern is we didn't learn enough techniques in our PhD curriculum, at least during my time. I sense that, I mean, if you look carefully at the OM community, 10 years ago, you see a lot of people doing call center scheduling. And then in a few years' time, suddenly everyone doing call center move into healthcare. These are all stochastic modeling people using the same tools, but addressing problems in different contexts. So these are scholars that approach the problems from methodology side. So when they are trained in stochastic modeling, every problem looks like a stochastic model. For me, I am trained in integer programming. I remember when I first went back to Singapore, when I talked to every companies, all their problems are integer programming problems or network design problems that I learned from Tom and Dimitris, because I only know integer programming. So if I'm exposed to more techniques, DP, reinforcement learning, I would have more tools in my arsenal to model problems and pick the right approach to solve the right problems. So I think the technical training provided by MIT is actually very good, and in fact, you should have more. Get the students to do more courses. Instead of 10, get them to do 20 before they graduate. So why stop at 10? Yeah. Why stop at 10? Yeah.
Okay.
This is my last word.
Yeah, I think on this note, I will let everybody go to lunch. I would like to thank you guys for accepting us.